I call myself Mr. U.S. Patil, working as assistant professor at Sharad Institute of Technology, College of Engineering at Rao, Ichalkarji, which is at Kolhapur district, Maharashtra. So, we are going through an example on B-spline curve. So, let's get started. As we have gone through a problem or example on Bezier curve, basis on that, uh, we can take a same problem or same example as of we taken for Bezier curve. So this is what an example. To find the equation of a cubic B-spline curve, the control points are P naught. There is world coordinate system that P naught 220, P1 230, P2 330, and P3 is 320. So given data was control points. These are the control points, 4 control points. So we know this, that n plus 1, that is 4 control points, and n is 3. This is p naught x, y, z coordinates values, and for p1 these 3, and p2 these 3, and p3 these 3. So now we have that B-spline equation, that p of u summation of n I equal to 0 bi ni k of u, where u lies between 0 to u max, where n I k you are the B-spline functions. Okay, so k is here the controls the degree, that is k minus 1 of the resulting B-spline curve. Say we are taking here k is 4, you may take k is 2, 3 or more, but you can't take k as 1. You should you take more than 2, because we need to join two control points minimum, so that is k. So this is what B-spline function has given this equation, ni k of u, that is equal to u minus ui into ni k minus 1 into u divided by ui plus 1 minus 1 minus ui plus, in the bracket, ui plus k minus u bracket complete into ni plus 1 k minus 1 into u divided by ui plus k minus ui plus 1. Say this equation 2 and this equation is 1. So now here we need the value of I, k, yes, and ui. What is u and ui? So u is a parameter which is always lies between 0 to n minus k plus 2. This is a standard, that is u lies between 0 to n minus k plus 2, and ui, or in some textbooks they have mentioned ti, we are using here ui is a parametric knot or knot values. You can say that join points at which piece of the curve joins. As I told you that it should k is what, not control of the degree. So this is what ui parametric knots on that basis. So we need to create a degree curve defined by control points, isn't it? So we need knots. How many knots will be available in this given points? So as we have taken k is 4, you might have take 2, 3, whatever you want to take. On the basis of k you will get the knot values. It might be changed as per the k values. If you taken, we are taken k value 4, so we get knot values are 8. So how could we find the knot values? That is ui 8 means 0, u0, 1, 2, 3, 4, 5, 6, 7, means these are the 8, means 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 knots we got. Yes, so here each knot value or ui value we got 0 if I value is lesser than k value. If it is not, if we got ui value is I minus k plus 1, if k less or equal to I and I is less or equal to n. Similarly, if both the cases are not satisfied if n minus k plus 2 will be there if I is greater than n. So we need to check whether in which equation it has to find. See, we take as ui is 0. Suppose I is 0. So from equation 1, as equation here 1 a, sorry, equation a, so ui equal to, if it is comes 0, there will be I less than k. So if I put I equal to 0 here, so it would be k is 4. We know that k is 4, so 4 is greater than 0, so it has satisfied. So if you take I equal to 0, that is 0 is less than k because k is 4. Similarly, if I take I equal to 1, so again 1 is lesser than k, that is 1 is lesser than 4. Similarly, I equal to 2, that is 2 is lesser than k because k is again 4. Similarly for 3. So here we can say here I value is 0, right? If a k value is 1, that segment 1, we can say that using 3 points, one a segment we can say that create. So here we can say here I value is 1 0 1 and 2 1 2, there would be y is 0, isn't it? So even 3 and 1 are even 0, 3 and 1 even 0, right? I have not written here. So there is equal to 1 if y equal to u equal to 0, right? So or else where 0. So from equation 2 here we'll see ui equal to I minus k plus 1. So if I use I up to 3 is over, further 4, if I put 4 here, so k minus I minus k plus 1, I means 4, k means 4 plus 1, so 4 plus 1 5, 5 minus 4 is 1. So again condition is what? K less or equal to I or less or equal to n. So k is 4, I is becomes 4, I is become 4 means I we have taken 4, so I is 4, n is 3. So again it is not at all satisfy, or you can say not, we can not use this. So again come to this third equation. If you go to third equation, so I should be greater than n. If putting I value in this equation, so if I is greater than n, so it would be satisfies with the this equation. So suppose I taken I is 4, that equation this 3 minus 4 plus 2, that is equal to 1. The answer is 1. Here I is greater than n because I, what we have taken, I 4 and n is how much? 3. So it answer is 1. When answer is 1, if putting 4 we are getting 1, the satisfied equation is I greater than n, so it would be satisfy the equation this 3. So for I4 it would be 1, for I5 also it's 1, I6 1, I7 it's 1. So we can say that 4 1 5 1 and 6 1, it would be 7 1, it would be 1, that is equal to 1, right, or 0 elsewhere. So next, if you got this all, so not value we got. So how it is? For u0 that would be 0. u0 means your ui is 0 equal you got 0, isn't it? 0, isn't it? This satisfies, this equation satisfies means ui equal to 0. If I is 1, again it would be 0. If 2 is there, 0, 1 is there, 0, 3 is there, this is 0 because it satisfies this equation. So here u0, u1, u2, u3 all are the 0 0. So 0 is 0, u1 is 0, u2 is 0, u3 is 0, and sorry, u3 is 0. Now u4, you can see here, u4 we got one value, isn't it? 1 1 1, it satisfies this equation. So here u4 is 1, u5 is 1, u6 is 1, and u7 is 1. So from this we can say that the u is range between 0 to 1. So again, from equation 1 we can write, like the equation as p of u, p naught n naught 4 plus p1 n1 4, p2 n2 4, and p3 n3 4. Means these are the 4 4 4 4 is k value what we have taken or chosen. 4, k is equal to 4. So this I value is 0 1 2 3. There are 3 points including that we have taking. So this is what b-spline curve equation, right? So next, if I from equation 2, that from equation this equation 2, so I can say that 0 2, because now see here, 0 1 0 2 is not there, 0 3 is also not there, 0 4 is not there, isn't it? I means when k equal to 1 there would be 4 points, isn't it? K is 4. So 0 1 0, sorry, 1 1 2 1 3 1. Similarly 1 0 1 is over 1 1, sorry. So this is what it values given is 0. That is why I am showing here, we are showing here. So here come to here, you will understand that, see, 0 2, that is I equal to 2 and k is 2. So u of I is 0, here ni is 0, k minus 1, k is 2 here, k minus 1, so that is 1, 2 minus 1 is 1. So u is into, this is u, and u minus 1 plus this is value, again n of 1 is ni plus 1, that is 0 plus 1 is 1, k minus 1 is 2 minus 1 is 1, u2 k plus 2 is I plus 2 is 0 plus 2 is 2, here I plus 1 is 1, 0 plus 1 is 1. So here we can say that u naught is how much? 0 value, u naught is 0, u naught is 0. So u naught is 0, u2 is also 0, u2 also 0. So this is u, this is 0, so remaining is u. So as it is remain here, and u1 is 0, u naught is also 0, so it becomes 0 plus u2 is 0, so minus u, so minus u is here, so n1 of 1 divided by u2 0 and u1 is also 0, so its answer will be 0, isn't it? So as we mentioned here, 0 1 0 2, you get 0 only. So now 1 2, I value has changed, means point has been changed, but the k value is not, the segment value is the in the 4 points, that 4 points includes one segment. So this is one segment, this is one segment, 1 2 3 4, this is one segment, right? And so now n 1 2, similarly put I is 1, here I is also 1, so all the values we have putting, we got this again equation, again it could 0. Now come to the point, I is 2 and k is 2. So this is one segment within using a 4 points, that is I 0 1 2 3. So putting I is 3 and k is 2, so again simplify this equation, we got this equation. So when you are saying here u minus u2 of n21 divided by u3 minus u2, u3 is 0, u2 is also 0, you know that, because u3 is 0 and u2 is also 0. So here this is 0, u4 is 1 minus u, isn't it? So u3 1, n3 1 divided by u4 is 1, u3 is 0, so again it would be 0. So we can say here this is 1 minus u of n 2 1 and 3 1. So it would be n of 3 1, means 3 I of 3 means segment of 3. First in segment there are 3 points, we can say that, because 1 is no there. And again this is come for 3 2. Again if you say solve this, you will get u of n 3 1, because segment 1 of I point 3. Come to the next, using next segment 4 2, so you will get again 0. Similarly 5 2, right, so you will get again this 0. Next segment 0 3, for k2 k1 is over, k2 is over, k equal to 3 comes, so I equal to 0 and k is 3, again you will get 0 here. When I is equal to 1 and k is 3, you will get 1 minus u square n 3 1. This you will get same throughout the equation. Whenever you solve, you will get this 3 points and one segment. This is 3 point and one segment. Next, this is 1 0 1 2 3, means 4.1 segment. This is k is here 3. Next, k is 4, so we'll get this equation again. So when you see all this equation, this ni4 into the equation 4. If I put this substituting equation in the 4, if I put all this in equation 4, so I'll get here that p of u p naught 1 minus u cube plus 1 minus u cube plus, this is 3p1 u into 1 minus u raised to 1 minus u raised to 2 plus 3p2 u square into 1 minus u brackets complete plus p3 u cube whole bracket, that is of n of 3 1. So substituting this into this equation gives the curve equation as, if you taking this, so we are comes to that this equation p naught 1 minus u plus 3 p1, sorry it should be 1 minus u cube, 3p1 u into 1 minus u square, it should be square, 3p2 u raised to 2 1 minus u plus p3 u raised to cube, but where u is lies between 0 to 1. So if you see this Bezier curve as similar as this, if you wanted to know the values of u is 0 to 1, so you can, previous example we have saw that u is equal to 1 3/4, u is equal to 1/4, and u is equal to 2/3, and u is equal to 1. If you put the values over here of p and u value, so again you will get the points where the curve we need to find. So this is what one of example of B-spline curve on the basis of Bezier curve. In this equation is the same as the on one of for Bezier curve that we have shown in the example previous. Thus the cubic B-spline curve defined by 4 control points is identical to the cubic Bezier curve defined by the same point. This fact can be generalized for that k minus 1 degree curve as we have mentioned earlier, isn't it? So We'll see the next topic next class. Thank you. Thank you everyone.